Welcome to the next episode of KapVista Klips. Today we have the team from Long Pipes. Neil and Stephen, how are you?
Good indeed. How are you?
Awesome. Now, I've known Neil for quite a while. I've seen him present across the globe. I know exactly what his offering is, and I have been excited about it for quite a while. But let's get into it from the beginning. Tell me about your background, what you've done pre-Long Pipes, and what brought you to this point. And I may cut you off because I know you can talk forever.
Yes, it depends on how many millennium we have available to talk. Yes, my background is actually science and law. So people are surprised that a solicitor is dealing in patents, and I've got almost 200 patents to my name these days. And it was because I started doing science, nuclear physics and geochemistry. So I was a science nerd. I won the science prizes for the school and all the rest of it. And I just happened to be adept at both science and business. And so I did commerce law instead of science and engineering. And from that, I went on to being a lawyer in corporate, commercial, and family law, and then criminal law as well. And one day I just decided, all right, I might end up being a judge or something like that. And I could look back on my life and say, well, I've created these fantastic laws. I thought, that's not what I want to do. I want to change. So I created Eagle Aircraft Australia, which was at that stage by far the most advanced light aircraft in the world and was the most advanced technology in the world. And set it up in my mother's garage and booted her MGB GT out and started the construction of the aircraft company, which became 12,000 square meters, 200 employees, and in the end became the largest aerospace group in Asia. And it's still operational in Malaysia. So from that, I had a background in aerospace. And when Mahathir decided that he wanted to own it rather than us, he took over, we stepped out, and we then created Quickstep Holdings Limited. Quickstep Holdings Limited was based on a technology developed in my garage. I'm sitting at home at the moment, and literally downstairs, we bought four $15 solar hot water systems, took them apart, turned them into a cooking mechanism for cooking composites with liquids. Nobody had thought about it before. We did, we patented it, and that created the Quickstep Holdings technology, which ended up building Joint Strike Fighter weapon systems and, well, basically everything you can think of in advanced composites. Quickstep is still Australia's largest aerospace group and the largest contractor for a Joint Strike Fighter outside of the United States. In addition to that, at the same time, we needed carbon fiber. So we invented a new way of making carbon fiber. That became Nexus, which is now owned in the United States and is one of the most advanced carbon fiber technologies in the world. At the same time as that, we won a contract with HSV to build lightweight vehicle for the world. And that was going to go into the Ford assembly plant. And that became the top technology in the world for that. And so we ended up contracting for doing Corvettes to Ferraris and all those sort of things, which did not proceed because the company decided it was going to go aerospace rather than automotive. So upon leaving Quickstep, because I didn't want to go aerospace exclusively, I could see that we were coming into the lightweight vehicle program for lightweight vehicles for electrical vehicles, for lightweight vehicles for fuel efficiency, and I didn't want to be aerospace weapon systems and space structures only. They wanted to go that way. The board decided it wanted to go that way, so I stepped out and went back into mining and back into our mining operations. And you were asking about how this came about. Well, I was driving out to our mining operations, which by that stage had absorbed a pipe production company, and it was installing pipes. And the pipes were breaking down at the joints. And we put in this whole lot of pipes at Barrow Island, and they were ruddy well leaking. 5% of the joints failed. So I had Trevor Gassotti, who was with the Australian cricket team. He's about 6 foot. Oh, he's huge, 6 foot 5 foot 6'6", slaving away in the heat, trying to put these joints together so they didn't leak. And he swore at me and said, you've got to make a long pipe that doesn't have any joints. And he was very aggro with me. And so you're not going to be allowed back in the office until you've invented this new pipe. So for about 6 weeks, I snuck in through the back door to the back office at the same time as being at the aerospace side 3 days a week. I was at our mining and pipeline side. One day I was driving down, I just dropped some US majors off in the city in Perth. I was driving down Kwinana Expressway, turning onto Roe Highway, and it was just so simple. I was moving the wheel between my fingers like that, and it was a tube. And the tube could be held between my knuckles. And each knuckle has a little gap in between. And each little gap could allow the resin to go through, but would stop the air getting through. It couldn't be that simple, could it? It was, and that's how Long Pipes was created. It took about 20 seconds as I was going along the curve and going out. And I walked into Trevor's, dropped my bag on the table and said, I now have your Long Pipe without joints. So I was allowed back in the office without skulking around the place. So that's how the Long Pipes process started.
Before we get to that, let's
Yep.
we'll get Stephen's background, and then we can
Yeah,
get
Steve's much more valuable than I am in many ways.
Yeah.
Thanks, Daniel. My background's engineering. So I've basically been a design engineer and operations engineer. I've worked for the last few decades with Woodside, which is one of the world's largest independent energy companies. So as I say, during my time at Woodside, I've spent time at the rock face, getting the costs of our operations down. I've been in projects, building things, been in the business side of it, working in joint ventures, and then as well as then moving through our development part of the business, and working out how to bring down the capital costs of projects. I ended up in our technology team there, looking at disruptive innovation. And it's during that phase that I actually came across Long Pipes. And initially my interest in Long Pipes was actually as a way to unlock our Canadian gas assets and to basically get gas to the coast, to liquefy it as LNG and ship it off to China and Japan, North Asia. Now, as part of that, the gas was there, it was cheap. The LNG plant, we had other designs to make that cheap. Really the Achilles heel was actually a cheap pipeline. And so that was my introduction to Long Pipes. I heard about it, I went down and introduced myself to Neil. And then I guess over the years, Neil and I have stayed in touch. We've obviously done technology qualification steps as part of that journey, just to get some kind of technical due diligence done. And then basically I left Woodside last year and was talking to my wife about how we're going to spend our retirement when Neil rang and said, hey, could do with a hand. How about you come down and help us out? And from a disruptive innovation perspective, I've spent a lot of time looking for competing products or products that can perform the function at the price point that what I believe Long Pipes can do. And I actually think it has a lot of potential. So I kind of jumped in feet first, and it's been an interesting journey going from the corporate background into the startups. But I'm enjoying it. It's been a wild ride these last few months.
Well, that's exciting. Now let's get into what Long Pipes.
Before we go on, there's actually a very interesting story that goes with this, Daniel.
Yep.
Steve and I, in the foyer of Woodside, declared to each other that we would work to decarbonize the planet, and that we would do so that our grandchildren did not say to us, we were part of the problem, we're part of the solution. And we shook hands on that. What year was that, Steve?
2019.
2019. And since then, we've said we're going to do this because the impact of it is global.
Yep.
There isn't any doubt about that. And that's what we found in all of our investigations and with all of the parties working on behalf of Long Pipes.
Yeah. So tell me about it. And I know you've got some props that you want to show to the camera, but tell me about the product.
In its simplest form, it's just a bag. It's a continuous bag made up continuously with a tube in the inside, which is basically a rubberized tube with a whole lot of fiberglass wrapped around that tube. And the bag on the outside, the tube on the inside, you pour resin in the bottom, and it fills the cavity between the inflating bag on the inside and the outer casing on the outside, drives all the resin up, round, and out through the little holes at the top, so as to only get the exact amount of resin required and no air. It actually got pioneered in its first iteration not the same way, but fairly similar, in the construction of the wingtips on our Eagle 150B when we were building those back in the Eagle days. So I knew that this could be done. Nobody else could conceive of it, but we used it for all the wingtip ends, the rudder tip ends, the tips, but we put it into a continuous process. So it's an incredibly long bag from 1 to 6 kilometers in length, and we just pour the resin in the bottom. So I actually have, you know, that classic one where they say, I actually have a cake that I made in the oven previously. Funny about that. And this is how it works. So there are the holes in the top. You can see the little pinholes. The resin's poured in the bottom, and the resin moves up either side. But as this bag on the inside here is fully inflated, it squeezes the resin and the glass together under compression. And as it does so, it expands and tightens every single fiber bundle in that tube. And if you can see it closely enough, you can see the linear lines of the 0, 90, 45, 45 in it. Now that is amazing, because the technology of this is so advanced. If I could get that in a fighter jet wing, I would be absolutely thrilled. But this is aerospace on the ground. This is structure that is stronger. We've now found, Steve used to rib me all the time that I had to come up with a universal pipe, just like Trevor Gassotti declared that I have to come up with a long pipe. Steve would say, this is the universal pipe. It has to do everything from cryogenic to very high temperatures, to handle sulfur and to handle acids and to handle, well, basically everything depends on the liner.
Yep.
We didn't think that, well, I didn't think that was possible. Well, Steve kept working on me, and lo and behold, just recently, our latest performance pipe using this technology has burst at 136 bar, which makes it stronger than steel for the same thickness and for the same size. Now, let's get that into context. That is globally game-changing, because we're multiples of the speed of construction of any steel pipe. I want to put it into context. Bow Steel, its facilities about the same size as Rottnest Island.
Yep.
We can outperform that in a small shed. It's not a very small shed, but it's about 5,000 or 6,000 square meters.
Yep.
And that would mean that our capital costs, our operating costs, and everything else are a fraction of that. So we can produce more pipe than some of the world's largest blast furnace, rolling mills, and everything else.
Yep.
Continuously, that's now lighter, stronger, and cheaper than any steel offering that we can bring forward.
It's also a lot more sustainable, a smaller impact on the environment, smaller impact on carbon. You know, you're ticking all the boxes.
I think you've become converted, Daniel.
I was converted years ago.
So yes,
just from an industrial user's perspective, it's guaranteed not to rust.
Yeah.
And that is one of the biggest ongoing costs for anyone with a steel facility, particularly near a marine environment. It can get into the billions of dollars rectification programs after a few years. So yes, that is a fundamental advantage not to overlook as well.
Yeah. Okay.
Yes.
So
in the case of CO2, it doesn't just rust; it just dissolves.
Yeah.
It doesn't even go through the rust phase; it just disappears.
Yeah,
so this is
clarify. You're talking about a steel pipe,
Yep.
where you have
Correct.
CO2 moisture.
Yep.
Yeah.
Okay.
CO2, moisture, sulfuric acid, etc. just basically dissolves. It doesn't even go red; it just disappears.
Yeah.
This is catastrophic for our world carbon capture storage programs. It just doesn't work.
So tell me about the milestones, the exciting bits.
The exciting bits. Well, firstly, I produced this thing and then set it aside for a while. I didn't do anything with it. I went back to running our aerospace side. That took 3 or 4 years before I actually pulled it out of the corner and actually started playing with it. It wasn't until about 2012 that I actually pulled it out and started playing with it, and then put it aside again because we had we have a number of companies that we're normally running at the same time.
Yep.
We're not doing that at this stage. We have one focus and one focus only, and that's long pipes. At that time, we were distracted by a filtration company, and that gained significant momentum, and that was Z Filter. And that was sold off in the end to Anglo American. And that company was distracting me from doing long pipes. So for a long time, I didn't do anything with it, even after I'd invented it. And it really wasn't until about 2015, 2016, once the normal process of this is we, the Grahams, step in, get it to work, get everything functional and work out what we need in terms of capital and everything else. Then we go to family and friends and say, look, this works. We'd like to do something with it. And then start the investment. And that started to roll in around 2014. By 2018, we'd done most of the development work. We'd spent around $15 million by that stage. And we had available to us technologies that were just becoming quite spectacular. They weren't completely right yet. And we then went around the world doing presentations. And yes, I've done lots of presentations in Europe and in the US and in Asia. And at one of those presentations, we had a group come up to us and say, we'd like to form a Prodco in the United States. And so we spent roughly $20 million putting that equipment together, developing the technology, demonstrating it. At the same time, in parallel, we did Albany, which was for a potato farmer. We did another one for an avocado plant. We did lots of different ones for Harvey Water. And then we went up to Laverton and did 10 kilometers of a main and about 12 kilometers all up of testing, which showed to us, okay, 2018, the equipment works fine. It's development. Put it in a box, sign the joint venture agreement, send it to the United States. Because the US market's got 5,000 miles of produced water, 25,000 miles of gas. It's got all of these new requirements coming up because of the shale market. And so we said, that's where we're going to send it. And we progressed with the joint venture. The product worked very well, in fact. And so that's where we sent the equipment. And now we've been undertaking certification. But because we don't have the equipment to make this stuff at 10 meters a minute, it's all having to be made by hand. So it's a lot slower. And that's why this capital raise at this point is we need money to build another pipe production machine and sock production plant so we can do certification. Why? Because they just announced the first carbon capture storage into the North Sea last night for green sands. It's massive, but they're not going to be able to do it practically without a pipeline. And we're the only technology that DNV is aware of that's going to be able to do this globally. Nothing. We're it.
Okay. So tell me about the raise.
That's the milestone. Sorry?
About the raise. You're raising 1.5 million. What's the offer? What do investors get for it?
Okay. 1.5 million. We want this to lead on to the larger capital raises so that we can go either ASX, a stepping stone to NASDAQ, or a NASDAQ straight. So we want to be able to put together the plants to produce sock production plant, pipe production machine, and to enter the Asian markets. We've been approached to do the Gulf of Thailand at the moment, which is significant. It's going to be drawing most of the CO2 out of the industrial areas of Thailand and burying it in the Gulf of Thailand. Roughly $30-odd billion. And our proposed Prodco partner in Indonesia and in Thailand is instrumental in this and will be putting forward proposals on this in the next couple of weeks. Whether we agree in the end, we don't know. Whether we go with that particular Prodco or another, we don't know the answer to that. What we do know is we have the technology to do this. In addition to Thailand, we're wanting to do demonstration plants in Australia. And the one that we'd very much like to do is in our Northwest Shelf area, which is up in the northwest of Western Australia. And that would be capturing of CO2, basically corralling it, sending it offshore and burying it. And that's 30 and 152 Ks. And Steve's far more familiar with that than I am, and he can talk on that in detail. So in addition to those flagship projects, we've got really basic ones like how do we make a really low cost, high pressure irrigation network for Africa? Because we've been approached by the Africans for 3,000 kilometers of the first. Oh, sorry, you just froze. So we've been approached for 3,000 kilometers of low cost, high pressure base pipelines. And that would be the start of a number of them. Also in Asia, we've been approached on that as well. We've only just brought out this new architecture. This architecture has only been around since basically November of last year when we were approached by the Africans. We love your super pipe, but can you give us a toned down version of it, something that's a lot cheaper for us to handle? And so that's what we've been doing. And lo and behold, once again, we've been approached from many different arenas because it's going to be cheap for slurry lines for mining. It's going to be cheap for water distribution. The markets that we're dealing with, to give you an overall ballpark, the market for onshore large diameter, that is foot and above, it's about 120 billion US a year. The offshore is about 120 to 140 billion. If you take into account the raw wet CO2, et cetera, you can increase those by 4 or 5-fold per year once they get going.
So Neil, I think
yes, Steve, please.
It's fair to say that in a lot of the things that get out to the media, there's a lot of in the technology space, there's talk about, for example, how to produce a product and how to consume a product, the other market. And I think Neil's outlined a large part of the market opportunity, but there's very little about the connection of how I get my product that I'm making from point A to point B. And this is basically the space that long pipe sits in. And so we're not going to produce the product and we're not going to consume the product, but we are going to enable that product to get to market. And essentially what this offer comes down to is that what our customers are consistently coming back and saying to us is we want a certified pipe. And the reason they want a certified pipe is that basically when you put a hazardous material and transport it from point A to point B, you basically need regulatory cover. And to get regulatory cover, you need to have certification. And so what this offer is about is to enable us to get certification done for our pipes. And in the future, we will be raising more money to build the SPM and the PPM. The question as to what the size of the market is, to be honest, that's unknowable because there's more or less no fluid around the world that doesn't get transported by a pipe of some description. Are we going to play in the really small bits of pipe? Unlikely. We're going to be in the main transmission pipe, the bulk transport of fluids, gas, liquids from point A to point B. And basically, so this offer was to raise $1.5 million US at US 40 cents a share with a 1 cent attaching option to each share, US 1 cent attaching option to each share.
Primary focus being certification.
Yep.
Certification is the prime focus.
And then that will enable you to complete these projects, Thailand, other parts of Asia, the Australian projects that you were saying, Northwest Shelf. And then beyond that, what are you looking to raise so investors know that there is an opportunity to get to the next point, and then you're looking at an ASX listing?
ASX and NASDAQ.
Yeah,
ASX is good because I've had 4 ASX listed entities. They're a good stepping stone to NASDAQ. You do a transition across to NASDAQ, and it saves a lot of time and money and effort. And it's also a good basis for us to establish our wares before we go across. So, yeah.
So
that sounds exciting, very exciting. And you fall into a number of interesting categories, not just manufacturing and engineering, but also the sustainability impact. And there's a lot of focus on clean technologies, and you fall right into that because you reduce the carbon footprint, not just in the manufacturing and production, but also cutting these large steel pipes across the country, across the world, very expensive and very big footprint on the carbon aspect of it.
Yes, we're roughly 1/5 the CO2 emissions per 1,000 kilometers of a steel pipeline. We're 1/3 of that of a polyethylene pipeline. But as you said, in logistics, we're roughly 20-fold different. So if we put a 6-kilometer container load of sock into, that's our bag basically, put our bag of fiberglass into a container. Sorry?
I was just saying, into a 40-foot container, a standard container?
A standard container. And take it out.
Essentially, I think where you're getting to, Neil, is a truck can take basically up to 6 kilometers of pipeline on the back, as opposed to a normal truck, which can only take 16-meter lengths.
Correct.
So the number of the logistics of a fluid highway solution is a lot less than the logistics of a steel pipeline installation methodology.
Depends on the size of the pipe, between 10 to 20-fold.
Yeah.
And the labor component's about 10%. So the cost overall is substantially reduced, but the speed of delivery is massively increased. So you can increase speed 10-fold or more. So this is
labor costs.
This is in later costs, and 40 to 70% is the sort of cost reduction you're looking at in comparison to. It's very hard because every single project varies. You can't give a fixed pricing on it, but it enables us to put in the hydrogen network. So we were talking about the new energy economy. Well, the new energy economy is dependent upon two basic parameters. Can you deal with your CO2? And can you transport the hydrogen? Everybody talks about going electric, but you can't go electric for heavy vehicles, and you can't go electric for industrial applications. It's just not possible. So what are you going to do? If you look at the JCB story, Lord Bamford is presenting his new hydrogen-powered earth-moving equipment, and it's all spark ignition, big diesel engine equivalent. Cummins is doing the same thing. The Ram utes coming out. They're going to make 25,000 of those in the coming year, and they'll all be hydrogen. And Caterpillar's coming out with theirs for their heavy earth-moving equipment. So everybody thinks of the hydrogen transition as being a long time away. Nah, it's by the end of this year, they will be in production on these engines. So the question then becomes, where are they going to get the hydrogen? Where's the infrastructure going to come from? Yep. How are they going to do this? So this is where this inner liner here, let me have one of these things back again. The inner liner here on this one is made up of an EVOH liner, which is pretty much the same as the inside lining on the Toyota Mirai, the Toyota hydrogen-powered car, which runs at 700 bar of pressure inside its tank. Well, that's the liner to the tank. So we've basically got a Mirai hydrogen tank, the full length of our pipe.
Yep.
And that means that in comparison to steel, we don't leak hydrogen. And steel really leaks hydrogen. It's just a sieve for it. And it ends up with rust on steroids. You take hydrogen and oxygen, which is water, and you put it up against steel. Yeah, it corrodes over a while. You take the hydrogen out of the hydrogen and oxygen, push that through, and it's like rust on steroids. And it's called hydrogen embrittlement. And you can get big chunks of steel and just snap them like Superman. And that's what happens. And so people are saying, oh, we're going to convert all the natural gas pipelines to hydrogen. All of our specialists who are in the field, such as D&V and Dennis Kirkman-And, who's the one of the 50 guys who are top in the world in the ISO, that's the International Standards Organization Committee, sits there and says, I have 49 members of this that are all steel-based. None of them can get their pipes to perform in hydrogen. I'm the only one on non-metallics, and I'm the only one that is still talking about transporting hydrogen. So this is huge on a global basis for the new energy economies.
Yeah. All right. Well, we'll leave it at there because we're almost out of time. But it was fantastic to speak to both of you. As I said, I've heard you present all over the world, and it just keeps getting better. But I'm excited to see what's next. Anybody who's watching this video and wants to find out more about what the team at Long Pipes are doing, let me know. I can connect you directly with the guys. And good luck. I'm excited.
Thanks
very much for your time today, Daniel.
All right.
Bye.
Bye.